Good afternoon, everyone.
Good afternoon, sir.
So, let me pull up our topics and let me find our material. So, that's going to be, yes, we stopped here on page 64. Great. So, what are our topics for, no, that's digital media. Information technology. Right, so our topics for paper 2 are computer fundamentals, networking, implications of misuse, word processing, spreadsheet, database, problem solving, and programming. If you notice, it's basically all of the main topics that we would have covered throughout IT. So if we check, if we check what we would have covered so far. So we actually covered our first topic here, computer fundamentals. So that was the entire chapter 1, which is the basics of hardware and software. There's no mention of information processing. Networking, we started that. So we're going to continue with that topic today. And we'll try to, so we'll be finishing off networking and try to start the implications of misuse and cyber security. So let's get back to that page there. Alright, so remember the session is for you guys. I will be going swifter than usual. So if you need me to repeat something, let me know. If you have a question, let me know. Feel free to unmute, type your question in the chat, whichever you're comfortable with, so that we can get the topic clarified to you. So in the last session, we would have started computer networks. We looked at the various configurations. We looked at the various configurations such as PAN, LAN, WAN, MAN. What is a standalone? What are wireless networks? What do you need to make a network? So we'll be continuing today alright, we'll start with the peer-to-peer network so we can have a clarification on that. So it says here that a peer-to-peer network basically refers to a network that does not have a file server. So if we were to look at a diagram, for example, this diagram of this network here. Say for instance, this computer here is what we would call a server. Now this server, as the name implies, it's to serve. It's going to offer some services. So it could be a file server, it could be a media server, it could be a print server, and as the name implies, that is what it's serving. Serving files, serving printers, serving media, whether if it's video, images, and so on. So when a network does not have a server, basically there is no computer offering services, any form of content, and so on. That would be called a peer-to-peer network. Why is it called peer-to-peer? Because basically everyone is equal on the network. No one is the main person on that network. So basically in a peer-to-peer network, anyone can be a server. So say for instance, with the same example here, there is no server in this network here, but say for instance, this computer here, computer 1, it has a file Say for instance it has a database file, and the other computers would like to access this database file here. So now when these computers here are accessing this file, the computer 1 will now be a server, so that it is serving that database file to the other computers on the network. The same process if another computer, say computer 2 over here on the right, if that computer has say another file, for example maybe a spreadsheet file, and computer 1 would like to access that spreadsheet, computer 2 is now the server in this case here. So basically any computer can be a server, basically because a server serves. It offers, it gives some sort of resource, whether it's a file, whether it's some sort of software or hardware. So that is what there is referring to as a peer-to-peer network. Are we clear on that?
Yes, sir.
Great. Now next we're going to look at the network layout. So we have 3 configurations for the network layout. We have a star configuration. Now a star configuration has a central device. The configuration is figurative, as in a figurative star. It's not looking like an actual star. So because if we were to actually look at a diagram of a network, give me a second. If we were to actually look at a diagram of a network, let's see here. Okay, I guess most of them are give the layouts actually looking like a star, but in real world examples, in the real world, the configuration in a room, it would not actually look like a star, but the figurative pattern is that it's looking like a star. So it's a central device. Previously we would have used a device called a hub, but today we use a device called a switch. They have the same functionality, but just that the switch, the network switch, offers you more functionality than the hub. So this is what this device looks like. So if you notice, each of the switch would have a series of ports, and the desktops or any device that is connecting via cable would connect via each one of these ports here. So thus this device here becomes a central device, which gives you the representation of a star. Now our next form of network, remember if you have any questions you can let me know. Our next form of a network is the ring network. Or did I miss the bus? Yes, seems I missed the bus. Yes, so the bus network is basically a straight line. You're going to have a central cable, as you see in the image here. You're going to have a central cable, and each device now is going to branch off from that central cable. So like this here, the blue line is going to be my cable, and from that central cable we're going to have a cable branching off going to each individual device. So the disadvantage of this here is that if this cable was to break anywhere along this line, then we are segregating the parts of that network. So basically only these two devices now will be able to communicate with each other, and this device over here, it's now all by himself. Now we didn't look at the disadvantage of this central network here, the star. The disadvantage of this network here is that if the switch is to go down, then that, since it's a central device, it will affect the entire network. So the entire network will go down because this central device, which connects everyone, will not be able to see each other. But if one device goes down, say for instance this device goes down, the network continues. Another device goes down, the network continues. So it does not. The star does not depend upon the devices. The main point of weakness is the central device, which is the switch. Similarly, for the bus, the main weakness is the cable. Any part of the cable breaks, that affects the connection between the devices. Now the ring network, it would, as you see in the image here, it basically connects all the devices in a ring. So it's kind of like the bus, but now we're connecting the ends of the cable. It's like if we're now connecting the two ends of the cable. So, and with the ring, it's important to note that the communication goes around. It goes in one direction. So it goes around like this here. So unlike the bus, which basically if you break a certain part of the cable, for instance, if this part of the cable here was broken, these two devices here would still be able to communicate because the signal can go back and forth. But with a ring, the information only goes one way. So if at any point the ring is to break, basically only this device here, say computer 1 here, can send information to computer 2. Computer 2 can send to 3, but it will not reach back to the computer. So 3 cannot send back to 1, 2 cannot send back to 1 because the link here is broken. Now, if you're wondering why do we have these configurations, why do we have the ring, why do we have the bus? Well, it's an older form of configuration. We do not use them anymore. The main standard that we use today is actually the star, because as you can see, the only point of weakness here is the switch, which is makes the configuration easier. But these two configurations, the bus and the ring, they were used in the past, and it allowed for a lower cost when it comes to creating the network. Because if you notice, it's a single cable, one single cable, and then a small branch off to the other computers. And then for the ring, it's one cable going to each computer basically. And then if you notice for the star, you have to get more cable in, a cable running to each computer. So that there with the star, it raises the cost. So when persons were creating networks, they looked at that. Not only which one is the best in terms of transferring data, communication, and so on, but which one was cheaper, which is the ring and the bus. But today, because cabling and equipment are much cheaper, the star is the main standard for today. Are we clear on all of that? We are following on all of that?
Yes, sir.
Alright, great. So our final configuration is the wireless LAN. So this is basically, think of it as an extension of your star, an extension of your ring, an extension of your bus, whichever configuration the network would have been created as. The wireless LAN is a wireless extension of that network. So simply a access point or a router, as we would call it today. So in your exam, you might see the term access point, or you might see wireless access point. So, or as we call it today, a router. We call it in our home a router, but it can also be referred to as an access point, a wireless access point. So this device here, and it attaches to the switch or the hub, but remember we use a switch today. So a cable runs from the access point to the switch, and that gives us the wireless part of our network, and that is what we called WLAN, which is an extension of LAN, the wireless LAN. So as you can see here, because of the the access point, wireless devices now can communicate on the local area network. So what other forms of wireless communication do we have? We have Bluetooth, which can be used to connect two mobile devices, a phone, two phones together, a phone and a tablet, even a phone with a printer. It forms that personal connection there, and that's why with that personal connection, that is how we get a personal area network, because you're creating that network, a small network, for a personal reason, basically for a personal communication. You're connecting your phone to a Bluetooth headphone. It's for transferring of that music, to listening to music there. Now we also have a hotspot configuration, which gives us the wireless communication. And hotspots, we know that can be set up on our phone, but hotspot is usually a term that also refers to Wi-Fi that is offered by a business or some form of organization that is freely open to the public so that they can make use of it. So cafes would use it, airports would use it, hotels would use it as a service. So it's basically Wi-Fi, but the term is referring to as a hotspot, where they can gain wireless communication. Now, a standalone computer, we already said basically it's by itself. No network is needed. It's used by home users. So you're watching a movie, you're playing a game, you do not need internet for that. It can be used for composing of music. You don't need any network license because you're not connecting to any network. You're secure from users because you're not connected to the internet. So there's no risk of being infected by any virus from over the network. But what's the disadvantage now? Well, obviously you cannot share any data. We know today we get to share data because of the internet. And because you're standalone, you cannot get to do that. But that doesn't mean we cannot share. We can share if we use secondary storage, which is our flash drives, our memory card, or external hard drives. We use that to transfer our data. So data can be transferred only by disk or a modem. So you connect it to a network if you do want to transfer your data, or you transfer by some form of storage. Now, when a computer is connected to the network, what advantage do you have? Well, you can access the network. So if the network has any resources, like for example, I mentioned earlier, the network can have a server, and that server can offer you services, can offer you resources. Like for instance, there's a program on the server, so you don't have to access it from your computer. You can access it from the server. There's a file on the server. You can access it from the server. So why is it on the server though? Well, think of it this way. Let me go back to this diagram here. This one here. So imagine each one of these computers here being in a different room. Totally different room. Room number 2, room number 3, room number 4. And the rooms aren't close to each other, but they're all connected on this network. And we're just going to say that this printer here is the server. We're just using it as an example. Now say for instance you're in room 1, you can access the server. But what if you leave room 1, you go by room 3 because you're spending time with your friend, so you're in room 3. But your boss call and tell you that he needs a file and he needs access to it. So, but you know the file is on the server, but he wants you to transfer it to him, for you to send it to him. So you don't have to run back all the way to your room, log on to your computer to access the file on the server. You could access it right from the computer in room number 3. So that's the benefit there of the having a network with a server. Any computer on the network will be able to access that server. Normally companies would give you a login information, so a username and a password, so that you can log on to that server and be able to access the services. So the other advantages, you can share files, you can send messages, share resources, as I've been mentioning so far. So you can access storage, CD drives, printers, modems, even share programs. As I mentioned, the server might have a word processing program, a spreadsheet program, and you access it from the server through your personal computer or through a workstation. So activities of network users, such as things as the amount of storage space available to users, can be controlled. So basically with this point here, the network is going to have what is called a network manager or a network administrator. Network administrator. Now this administrator now can control what the employees are doing on the computer. What can they do on the computer? So that's another benefit of the network. They can say that the computer should only have 40 gigabytes of storage, so that as an employee, you cannot misuse the computer. You can't go on the computer, download a set of movies, download a set of games, and do whatever you feel like with the organization's resources. So they can limit how much storage you're gonna get, what access to what programs you can get. All of that is possible because you're on that network. Now, what is the disadvantage now? Well, obviously you need all the equipment to create this network. So you need a network card. A network card is basically a device that allows you to connect to the network. So let me show you an example of that. So a network card. So we have wired network cards and we also have wireless network cards. Now this is an example of a wired network card or an Ethernet network card, so that you can connect an Ethernet cable to the computer. Now today, your desktop, they would have this card built into the system. So it's already built onto the motherboard. But years ago, the card was not built onto the system. So it was actually like an accessory. You have to buy the card, put it in order for you to get network access. Because in the past, the network was now growing, so it wasn't seen as a need to add it. But today, there is a need. And this is what a wireless network card would actually look like. Basically the same to the wired, but just that it now has an antenna. So if you want your desktop to actually be wireless, you can actually use one of this inside of your desktop computer. A wireless network card for a laptop. This is actually what it would look like. So this is actually what is in your laptop that is offering, that is going to allow you to get wireless connection. These gold rings that you see at the top, a cable will be connected to them that is running to the antenna, which is around the bezel of your monitor, of your screen for your laptop. So right around the screen of your laptop has the antenna for your laptop, and a cable will be running from this gold contact here to those antennas there. So that there's a network card for your network. You need cables, you need hub. Remember we said it's now a switch. You need a server, and all of that can be costly. That's why most small businesses, they don't care about setting up all of this network. They just do the basics. Now, if the server stops working, then basically the employees cannot work in the organization, because say for instance, the purpose of the job, the organization deals with editing videos. The purpose of the organization is to edit videos. So on the server is where they're going to store their movies. Say it's a movie company. On the server is where they're going to store the movies. Now if the server goes down, obviously they cannot access the movies to be able to edit them. So that's the disadvantage there. The server goes down, they cannot access what they need to carry out their job. Now, poor security. How is a network having poor security? Well, remember I said in the diagram above here, in this diagram here, you can be anywhere on any one of the computer and access any resource from any computer once it's connected to the internet. So that's a benefit. But that's also a disadvantage, because someone can go to this computer here and be able to access the resources. A bad person, a hacker for instance, can log on to any one of the computer, or even once he's connected to the network, he can access the resources. He can access all of the computers, see what they're doing, and that there leads us to poor security, because that person there can infect the computers with a virus, see what files are on the server, take them, and so on. And lastly, we talked about having a network administrator, network manager, who is going to monitor this network, ensure everything is working. That's a whole job by itself. So having to hire somebody to monitor this network can be a disadvantage to the company, because it will be costly. So that is the advantages, that's the disadvantages of a computer that is standalone, which basically means it's not connected to a network, and a computer that is connected to the network, so a networked computer. Are you guys clear on all that?
Yes, sir.
Alright, great. So next we're gonna move on to communication channels. What is a communication channel? It is basically a method or a medium that you use to transmit data. A communication channel could be in any form, because the purpose of it is to transmit data. So say for instance, you guys know of taking two cups, attaching a string to it, and being able to talk into one cup and you hear it through the other cup. What do you think would be the communication channel for that? You have two cups, a string is attached in the two cups, you talk in one cup, the other person hears the other cup. What do you think would be the communication channel?
So the string.
The string, very good. So the string is what will facilitate the transferring of that data. So anything that facilitates the transfer of that data is called a communication channel. So our cables, our Wi-Fi, our wireless signals, radio waves, and so on, those facilitate the transmission of data. Now, communication channels include, so what are the characteristics? What makes up a communication channel? Well, the transmission mode, the direction of data flow, transmission medium, and the speed. So the first characteristics we're going to look at is the transmission mode. This refers to transmission modes or rate determine the number of characters that can be transmitted in 1 second. So what are the modes that we have that we're currently in use? Well, we have asynchronous. Asynchronous refers to basically data is transmitted at irregular intervals and at a low speed of 1 character at a time. So basically the asynchronous, it's going to be slower than the synchronous method. Why? Well, when we're transferring data, we have two terms that we need to take note of: download and upload. So that's when we are transferring data. We upload data and we downloading data. So when we're sending data, we are uploading. When we are receiving that data, we are downloading. Now, asynchronous, how that works is that we are going to have a faster download speed So this is going to be faster, and the upload speed is going to be slower. You guys ever notice that? Your download speed is actually faster than your upload speed. No one ever noticed that? You never notice when you try to send a video, send a picture, it takes longer than you can actually download that picture or image?
Yes, sir.
Yeah. So that there is called asynchronous, because the download is actually faster than the upload. So that's why it's slower. So the synchronous method now is when the data is going to be sent more regular. So that's why this one, the asynchronous, is called irregular. The download and the upload are going to be the same. So say for instance, going back to the asynchronous, say for instance you have 10 megabits per second of download, you might barely have 1 megabit per second for upload. But for the synchronous, if you have 10 megabits for your download, it's going to be the same 10 megabits for your upload. So it gives us a much higher transmission of data. So that's the difference there between those two transmission modes. Asynchronous, it is slower, it sends the data irregular. Download is faster, upload is slower. And synchronous, the data is regular, it has higher speed. Why? Because the upload and the download are both the same. Great. Now the other characteristic is the direction of data flow. How does data flow across this communication channel? Our first method is simplex. Now simplex, the data only flows in one direction. So think of a cable. Think of this line here as a cable. The data only goes in one direction. Either goes to the left or it goes to the right. It doesn't go both way at the same time. Does not go both way at the same time. Only one. So you can think of your television, radio, when you're sending something to print to your printer. Those are simplex method. You can also think of simplex as being a one-way street. So the radio channel, the TV channel, it sends data to your television, it sends data to your radio, and that is called simplex. Data is only going in one direction. Now half duplex, the data can flow in both directions. Now it can flow in both directions, so it can go both way, but only one at a time. So for example, a walkie-talkie, that is a half duplex technology. You can speak to the person can speak back to you, but you cannot speak to them at the same time because the data won't flow at the same time. And finally, full duplex, both data can be sent and received at the same time. So you can send and receive at the same time. So that's what we're using today. When we are on the internet, when we are on a network, that's what we're using today. We're using full duplex. We're sending and receiving data at the same time. Now, one is not better than the other. That's important to note. For these direction of data flow, one is not better than the other. Yes, full duplex has more advantage. You can send and receive at the same time, but that does not make it better. Why we have different directions of data flow is simply because what do we need to carry out our whatever we need to be carried out. So say for instance the same radio and television. Do we need to send back data back to the television channel, to the radio station? No. we do not need to send data back to the television. You're just watching the TV. You're just listening to the radio. You don't need to send back any data. So you don't need the television and the radio channel to be full duplex or even half duplex, because all you need is for them to send you data. But when you do want to give a response, and say for instance the same walkie-talkie situation, you don't need the communication both ways all the time, then half duplex might be more suitable. But when you do need that reaction, that right away sending and receiving of data, that is when full duplex is going to be put into use. Alright, so next we have our transmission media. Our transmission media now is what are we going to use to transfer our data. So we have cabled transmission media, we have wireless transmission media. For cable, we have twisted pair, we have coaxial, we have fiber optic cable. For the wireless, we have satellite, microwave, infrared. Now these are just a few examples, and there are more out there, but these are just the popular ones that we'll focus on. So for the cabled transmission media, we have the the twisted pair or the Ethernet cable. Now the Ethernet cable is basically the most popular one that we use today. It is used by telephone lines. Why? Because it is cheaper to handle, it's cheaper to make use of. So we have different versions of the twisted pair. We have not seeing any image here. Yes, so this here is an example of the twisted pair. So this one actually has about 8 cables inside of it. So Ethernet cable. Yeah. So inside of that cable has 8 cables inside of it, 8 pairs of wires. Not 8 pairs. 8 individual cables inside of it, and even the telephone cable that plugs into your telephone, that there RJ14 cable, I think, if I can remember clearly, that's the RJ14. Yeah, even that cable there, that is also a twisted pair, but it has 4 cables inside of it. No, that's not it. Yeah, this one here. So it's still a twisted pair, but this one here, the RJ14, which is the one that plugs into your phone, that one has 4 individual cables. The Ethernet has 8 cables. Now, why are they called twisted pair? Well, because the cables inside of them are twisted. A pair of cable inside are basically twisted. So for example, the Ethernet cable has 8 individual cables, and when a pair of them are twisted, we now have 4 pairs of twisted cables inside. Now for the twisted pair, we have 2 types. We have the unshielded twisted pair, which is called UTP, and we have the shielded twisted pair, which is STP. Unshielded basically mean that if you look back at the cable, RJ45, that's the name of the cable. So the RJ45 cable, let me look at the internal. Yeah. Good. So you can see with this cable here, it's just the covering for the cable, and then you see the copper. Now if we were to look at, so I'm going to search for UTP versus STP, so you're going to see the difference here. So the difference between the two here. So the unshielded twisted pair is basically that plastic covering over the copper, and the shielded twisted pair has more of a shielding over it, has more of a protection over it. What is it protecting? It is protecting against EMI, which stands for electromagnetic interference. Electromagnetic interference, yes, that. So the cables can suffer from interference from other electrical sources. So the UTP is more prone to that, and that's why they developed the shielded twisted pair cable. Now, we already talked about the phone cable, the STP, and the UTP. Good. So that is it for Ethernet cable there. Now next we have our other medium for transmission, or wired medium, is the coaxial cable. The coaxial cable, that is the cable you have connected to your television. The same cable that is running from your antenna to the back of your television, that looks just like this here. Let me get a better image for you. The coaxial cable. Yes, so this cable here, this is the coaxial cable, and it can be used for internet purposes. So cable companies, they would use it for cable television, and what they realize is that they can also use that same cable for transferring other forms of data. Hence, we come to this term called broadband, which is important to note. Broadband refers to the ability to be able to transfer a wider range of signals or a wider range of frequencies. Broadband refers to transferring a wider range of data or frequencies. So, what kind of data do we normally send across a cable? We would send voice data. We would send normal data such as text and so on. We would send video data. So different forms of data. Hence, if you notice, so if you notice this channel here being called a voice band, which basically means that voice data is going to be transmitted across this line here. Now, a broadband channel allows you to send more types of data, more types of signals across that cable. So that is what cable companies realize with the coaxial cable. They can now send different types of data. They realize they can send the television data and the internet data across this cable at the same time. So for those of you who might know e-networks, they would have started off using the cable, and by the use of the cable, you could get the cable television, and at the same time, you could have gotten cable internet from them. Now, our final cable, which is the more popular cable that is being used today, because it is much faster than the two mentioned before, the Ethernet and the coaxial. So the fiber optic cable is basically going to have a glass fiber inside of it. Some are also even made of plastic, PVC, because that way it is much cheaper. But the higher quality ones are going to have a glass inside of it. So how does the fiber optic cable, what does it look like? So this here is what a fiber optic cable would look like. So each of these individual clear strands that you see at the end, that is the glass or the plastic part of it. That is going to be used to transfer the data. All the colors that you're seeing, that is basically the coating, the covering to protect the medium that is being used to transfer the data. Now, fiber optic uses light to transmit the data. Unlike the Ethernet and the coaxial, which is basically copper, they're using electricity to transfer their data. So that means other electrical appliances can interfere with the signal, hence EMI. So that is basically also why you don't run the cable next to other electrical cables, because it can cause interference. Now, fiber optic allows us to eliminate electrical interference because we're now using light. So it's less prone to interference, but it can still be affected with if other light sources and so on can affect it. Now, the data can be transferred for longer distances, and that is why the internet backbone, if we were to look at the internet, the configuration of the internet, this here is the configuration of the internet, and each of these colors that you see in here is actually a fiber optic cable. So imagine this here is South America, and at the top here we have North America, and their cables running from South America to North America. That there is because of the fiber optic cable. They're running basically on the ocean floor. Now, good. So that's it for our cable media. Are you guys following so far?
Yes, sir.
Yes, sir.
Alright, great.
Yes, sir.
If you guys have any questions, let me know. So our wireless transmission medias now. So for wireless, we are going to have microwave technology, satellite, infrared, microwave. That is a short waveform. Basically the same as your microwave that you have at home. Hence why it is called a microwave. Now, satellite, it's using microwave technology also. But when it comes to these satellites, when it comes to using antenna technology, these wireless technology, there are basically two forms that you should note. One is that it sends a signal in a line of sight method. Two methods, yeah. So it sends a signal in a line of sight method or a scattered broadcast. So line of sight basically mean that it sends the signal in a one directional method. Let me see if you can find a diagram of that. Alright, let me Google line of sight. Should have done that. Line of sight versus scattered. Good. So line of sight, looking for configuration of both. Alright, either way. So line of sight is, as you see in this diagram here, as the name implies, the two antennas have to see each other to be able to access the signal. So as you can see in both ends here, we have two antennas, and if something appears in the middle and blocks that line of sight between the two antennas, it can affect the signal. So it's kind of like how when you go into a building, when you go into a very large building at that, the signal to your phone, it gets weaker. Why? Because the antenna could be of line of sight and it's not picking up, and your device is not picking up your that signal there. Now, a scattered broadcast, that is basically the antenna scattering the signal in multiple directions, and so it doesn't really matter what is in the path, but the disadvantage there is that one is going to allow you to transfer further. One is going to allow you to transfer the signal further. So I'm not seeing a diagram of scattered, but basically scattered, it sends the signal in different directions versus omnidirectional. Let me see if I find something. Yeah, basically like this here. Think of the center here as being the antenna, the center of this circle here as being the antenna, and what it does, it basically broadcasts a signal around in a full 360 degree. It transfers that signal, so it doesn't matter where you go, you'll be able to access that signal. So, but what happens there, the disadvantage of that is that the range is going to be shorter. The range is going to be shorter because it's using its strength to send the signal around in a 360 degree. So it can't send it that far. But if it was directional, it would be able to send it, it will be able to focus that signal in one direction, hence it will be sent much farther away. So that there is the advantage and disadvantage of those two types of signals there. Great. So that is it basically for our communication, our communication channel. We just covered all of the characteristics there. So remember the transmission modes that refer to how the data is going to be transferred, which is asynchronous, synchronous, the direction of data flow, simplex, duplex, and half duplex. The transmission medium, what are you going to use to transfer the data, whether it's cable or wireless. And the transmission speed, it wasn't mentioned, but basically it's how much data can be transferred. So for fiber optic, it allows you to transfer more data than the Ethernet and the cable. Now for wireless technologies, in the past they weren't as fast as Ethernet and Coaxial. The Wi-Fi, the data, and so on, they weren't as fast as Ethernet and Coaxial, but today they're kind of picking up in the in that area. So as you know, we have 5G today, and that gives us much faster rates than our than even some DSL connection, because 5G, if you were to search for 5G transmission speed, 5G, so as you can see here, 1G wireless connection. Let's look at 2G. 2G allowed 10 to 100 kilobits per second. 3G allowed 10 megabits, and that's what some of us are using at our homes right now, barely 10 megabits. But 4G allows 100 megabits. 5G allows 1 gigabit. And imagine our wireless, our wired transmission media, our wired internet is still stuck at around 10 megabits per second, and some wireless are even much faster than that. Cabled transmission speed, let me see if I get some rates for those cables. Let's see. Yeah, so this is a good diagram here. So the twisted pair can allow up to 100 megabits per second. If you're using microwave, it can give you 600 megabits per second. If you're using satellite, 600 and above. If you're using coaxial, it can give you 1 gigabyte and more. And if you're using fiber optic, notice it's giving you over 6 terabytes. So fiber optic is actually the fastest that we have at the moment. Great, so that's our transmission speeds there. Now intranet versus extranet, what are they? What is the difference between the two? Now intranet is a private network. all of us, we are accustomed to the internet. We go on the internet, we browse, we look at pictures, we download games and movies and so on, we access services. But the intranet is a private network whereby only a business or organization will be able to access it. Now, no one outside of that business or organization will be able to access it. It's only up to that business. Now, the intranets will be protected by devices such as a firewall, proxy server, which is going to act as a gateway. It's going to filter internet sites. So basically, some intranet, they will not even allow you to access the internet. What do businesses, organizations use the intranet for? Distributing documents. So remember, documents are personal to the company. They don't want it to be out on the internet. But the employees need to see it. So we're going to use that private network to share the documents, share the information, distribute any software, access any database, any staff training, group work, teleconferencing. Basically, whatever deals with the business, they're going to use that private network to keep it within the business, keep it within the organization, so that the information doesn't get out. We know today, hackers, they mainly use the internet in order to hack a company or organization. So, by eliminating the internet, you are thus eliminating a risk of being attacked. Now, what is the extranet now? The extranet, now, the intranet is a private network. Now, what if you want someone external? So, I like to use this diagram when I'm explaining this here. So, on the left hand side, we're going to have the intranet. And the right hand side, we're going to have the extranet. Now, the intranet, we're going to have a network. So this is a central device, a computer here, a computer here, a computer here. So this is the private network here. So this here is private. Now, the internet is going to be here. So this is the internet. And it may or may not have a connection to the internet, but in most cases it will not. So this is just going to be a private network. So it might allow some services on the internet, but in most cases it's going to completely block out the internet. So it's a private network here. Only these devices here can see each other. They will not be able to go on the internet. But one thing to note is that how this intranet is set up is that it kind of looks like if you're on the internet. You actually use a browser and you log on to different pages using that browser. So it kind of feels like you're using the internet, but it's not. Now, a private network, so that's the intranet. Now the extranet now, say for instance, we have a supplier. Let's say there's a supplier over here. So say on the left hand side, once again, this is Samsung. And no, we're going to say it's Apple. So over here is Apple. Now on the right hand side is Samsung. Because some of you may know that Samsung actually sells displays, the screen, to Apple. So Samsung as a company, they're gonna have their network here. They're gonna have their network, and they're supplying to Apple. So what they're gonna do now, this here is the internet. What they're gonna do now, well, they will use the internet in order to form their connection. But the main idea is that from Samsung's network, they're going to have a direct connection to the intranet over here on the right left hand side. So say for instance there's a computer on this intranet network here. So this green one here, I'm just going to name it PC. And what Samsung is going to do now is going to have a private connection to this computer here so that it can access some of the information that Apple wants it to see. So maybe like for instance the inventory. They want Samsung to see how many displays they have in stock, how many are being sold on a daily basis, how many are being used, certain information. So with that information now, Samsung can determine if they should send displays over to Apple, if they should supply Apple with their displays or offer any other services that they may be offering that Apple may need. So once again, the intranet is a private network. Only those in the company or organization will be able to access it, see the resources. But the extranet is a private connection to that intranet so that they can maybe access the services or see some sort of information that will be necessary. Now, this brings us to a term called EDI, electronic data interchange. Electronic data interchange. So this is what they would use to transfer those private and personal information between the intranet and the extranet there. Good. So that brings us to the end of that chapter there. Now, are you guys following on that chapter there?
Yes, sir.
All right. So our next chapter, web technologies. So what services, what features, what do we get from the internet basically? Now, the internet, what is the internet? The internet is basically described as a network of networks. So if you were to look at a diagram of the internet, so each and every home, each and every business, organization, they would all have a network. Now, when each and every one of those networks now connect to each other. So think about it. Your home is connected to GT&T, which is your internet service provider. The other organizations is also connected to GT&T as their internet service provider. So technically, we are all connected. Every person in Guyana is basically connected. All networks are basically connected because everyone is going back to this central organization, which is GT&T, Digicel, or E-Networks. But even if you have different providers, these different providers are actually connected to each other. So GT&T is still in some way connected to Digicel. Digicel is still some way connected to E-Network. And because, so imagine each dot as being a network. So because each network now is now interconnected to another network in some way, that basically is the internet. So that's how we can describe the internet as being a network of networks, because the various networks in the world, we are all connected. All networks are basically being connected. Well, public network, because we just learned the intranet, that's private. So your mobile phones, your laptops, your computers, your servers, mainframe, supercomputers, they're all linked together because of these network, because of the internet. Now, Why do we use the internet? We use it for advertising, we use it for emails, making orders and requests, to reach an international audience. So we're no longer limited to persons we know in our country. We can now reach quickly, more effectively, persons in other countries. What services do we get because of the internet? We get email, which is basically a replacement for letters. Now we can send messages to persons via email. But businesses today use it more as a professional means of communication. Email standing for electronic mail. We get data exchange. Another benefit of the internet, you can send data, you can receive data, you can send your photos, send your music, download your photos and music. We get instant messages. We can now quickly send our messages to person. So this is like an improvement to email. With the email, you did not get any confirmation that you sent out an email. So with instant messaging now, you now can get a confirmation that the person received it, the person read the message, and you can even send more types of data: text, images, video, audio, all in real time. That's the main point there, in real time. So your Facebook Messenger, WhatsApp, those are all instant messengers. Now the other service we get because of the internet is basically the World Wide Web, which allows us to access various websites and web pages around the world. And we know we access these websites and web pages so that we can gain certain services. Like for example, we go to Facebook so that we can get a social interaction. We go to YouTube so that we can have entertainment, and so on. Now the file transfer protocol, another feature that we get because of the internet, as the name implies, it is used to transfer files. Protocol meaning a set of rules or procedures that you're going to follow. So the FTP is a rule that you're going to use to that the internet or the software follows to transfer files over the network. So for instance, who would make use of it? Microsoft, they would make use of it to send out updates. If you're sending files, maybe the service provider might use that to send files to the other person, and so on. Now, how do you connect to the internet? What devices do you need? Your main device that you're going to need to connect to the internet is a modem. That's the first device that facilitates the connection to your ISP. So network configuration. Where is the internet? So we can use this example here. Good. So at the bottom left here we have the internet, and well, from the internet that will be given from our ISP, which is called the Internet Service Provider. Then you would have a cable running to your home, and that cable would be connected to some box in your home, and then another cable coming into your home, and that will be connected to maybe the landline or something in your home. Now with that cable, say for instance this firewall here, that is the this firewall here, this is the modem. So this is just a more technical configuration of a network. So from the ISP, you're gonna have a connection to your modem, and then from that modem now you could connect other devices such as your router or your switch which gives you other services. So for instance, we know that the router is going to give us the WLAN, or our wireless LAN, so that we can connect wireless devices, and our switch is what is going to give us that local, which is the wired network. And each device must have a network card, which we talked about earlier. So must have a modem, must have a router or a switch. Important to note that some of these devices are actually built into each other. So if you ever see that you have one device basically in your home, that's basically all three of them working as one: the modem, the router, and the switch. If you see your router having multiple ports at the back, that basically means it has a switch functionality built into the router. So these three devices are needed. In addition to that, you need a network interface card or a network adapter that's going to allow you to connect to the network. You need some sort of software that is going to make the device operate, and for example, a browser application to access the services. And then lastly, you need someone that is going to offer you internet services. Someone is going to offer you that connection, hence your ISP. Now, what is a modem? A modem is a coined word for modulator, demodulator. The signal that is coming from your telephone line, so this signal here that's coming from your telephone line is a analog signal. And we should know that a computer is a digital device. Basically means that it sees only binary, which is basically ones and zeros. So analog and digital, they do not mix. So as the data is being sent in an analog form across the telephone line, something has to convert it into a digital signal so that your computer can use it. That is the modem. So that's the main purpose of the modem, converting that signal so that it can get that communication between your digital devices and the analog signal. Alright, so we already talked about the purpose of the modem, the router. We talked of the purpose of the switch, and we also talked about the purpose of the network interface card there. Good. Are we clear so far? Are we following so far?
Yes, sir. Yeah.
Great. Remember, once again, you have any questions, just let me know. What other services do we have? Well, we already talked about the World Wide Web, which is basically websites. Now, how does a website work? That's important to note there. How does a website work? Well, a website works by, so say on the right hand side here, so say this is the website. This is the website. Now, the website is going to have a normal network configuration. Every network configuration around the world follows what we've been learning so far. They're going to have a switch, and then they're going to have their computers connected to the switch, creating their network. Now on that network, they're going to have a server, and this server is going to be a web server. So the website is going to be on this server here. Now you, on the left hand side here, you are going to have your own network configuration. So this is your laptop here. And once again, your laptop is going to be connected to the internet, like this here. So your laptop on the network, connected to the internet. So when you type in that website now, what happens is that that signal is sent, that address, that request is sent to your switch, then sent to the router, to the modem, then sent to the ISP, and the ISP now is going to try to find that web server that is connected to the internet. So let me draw in that part there. So say the internet is at the bottom here for the right hand side, a connection from their router to switch and modem to the internet. So from our ISP over here, ISP is going to send out that signal, is going to ask who has the that web address, and then it's going to be sent over to their network here. The signal sent through the network and being connected to send directly to that web server, and it's going to make a request to that web server that they would like to see view that website or use whatever service that is on the website. So that is basically how the World Wide Web works. That is how websites work. On the internet, a web server will be connected to the internet, and we basically make a request to that web server. Now, what are the internet service that we have today? Well, at first we had dial-up. That was our very first form of internet connection. It was the slowest, so that's basically why we don't use it anymore. And it used the normal phone line that we still have in use today, that we actually use for broadband. But the technology, it's not the cable, it's the technology that they use to offer the internet service made it very slow. Dial-up internet, let's see what we get from that. Nothing really of use, but this is a simple diagram of it. So the internet connected to your ISP, your internet service provider, and the telephone cable is going to be run into your home, connected to a modem, and then connected to your computer. Oh, one thing to note is that dial-up, we didn't make use of so much of routers and switch. Why? Because with this modem, with this dial-up connection, basically in most cases only one device was allowed to be connected to facilitate connection. And I guess today with dial-up is still being used today. I guess today they can facilitate more, but it was mainly used with one device in the home. Now, the disadvantage of that, it was slow, and the other disadvantage is that, remember we talked about earlier about broadband. Broadband meaning that we can send various signals across this communication channel. Now, dial-up is what we would call a narrow band. Dial-up is what we would call a narrow band. Why narrow? Because it only allowed for one type of signal or a fewer amount of signals to be sent across the line. So basically with dial-up, when we were using it, we could have only used the internet or the phone. It wasn't both at the same time. Anytime you were browsing the internet and somebody picked up the landline, you would get disconnected from the internet. Why? Because it only allowed that landline signal to be sent across, or the internet signal. It cannot send both at the same time. So that is why we moved away from that to broadband, which facilitates more types of signals. So now you can be on your landline and browse the internet at the same time. And now we can even do more. Send voice, send video, other forms of data across the internet. So broadband is what we would call a DSL type of service, which DSL stands for Digital Subscriber Line. Now, the other form of internet, the cable internet, which is basically given to us by the cable company. So the same company that gives us our cable television, they, as mentioned already, they realized that they can send other signals across the channel, so they started using that for internet. So we call that cable internet. Now for our wireless methods, we have 2G, 3G, 4G, and today we have LTE. And the G basically refers to generation. So second generation, third generation, fourth generation, and so on. And I already showed you the speeds earlier. Now, what's important here to take note? Well, I already explained dial-up. For DSL, just like the transmission modes, we have asymmetric DSL, and we also have symmetric DSL, which basically goes in line with asynchronous and synchronous, which basically means, if you can remember, that with the asynchronous or the asymmetric, the download is faster and the upload is slower. And with the symmetric, it means basically the upload and the download are the same. ISDN, that is another form of internet connection. It's basically combining more dial-up connections to give you a internet service. We also have what is called the lease line, which is basically a dedicated communication line. Now, back in the past, what persons would do, they would rent the communication line, the same phone cables that would be set up. They would rent that cable basically. So that's why it's called a lease line. So they get a more dedicated connection. Then we have cable, satellite, and wireless. So as I mentioned already, wireless, a wireless internet connection or a wireless application protocol. I thought I mentioned wireless access points. Right? I guess it also has another meaning there. Alright. 2G, 3G, what services do we get with them? Well, 2G, when it came out, we only got text messages, some form of multimedia. 3G allowed us to start downloading videos, sharing more pictures, and so on. 4G is more like 3G, but allowed us to do carry out the transfer much faster. And the same for 5G today. Same like before, but facilitates everything much faster. Alright, great. Are you guys following so far?
Yes, sir.
Alright.
Yes, sir.
Good. So we have some terms that you should take note of. Now the first term is called Internet Protocol or IP. Now we also have what is called Transmission Control Protocol. So there are two protocols. There is TCP and then there is IP. So Transmission Control Protocol and Internet Protocol. But what happened is that they can work hand in hand, and that is why they are basically combined to work together. Transmission Control Protocol, as the name implies, it is used for the transmission of the data. That's what facilitates the transmission of the data. Now, the IP or Internet Protocol is what facilitates the identification of the devices on the internet. So just like how you would have an address, your home has an address, and somebody from America sends a letter to you, they would write on your address so that they can find where the letter basically has to go. Now similarly, when you type in google.com, facebook.com, how does it know where to go to access the web server to get this website? Well, it has to use a address. What is that address? That address is called a IP address. Pretty sure some of you have heard about this before. The IP address. So basically, the Internet Protocol address. And I'm pretty sure some of you know about some of them, such as the ones on your network, 192.168.1.1. So these are all forms of IP addresses that are used on the internet. So each device has an address in order to identify that device to facilitate communication. So that's the purpose of IP, and that is the purpose of TCP. TCP for transmission and IP for address. Now, why is it that you don't actually type in the address now? Why is it we don't type in this address here? Well, I'm sure none of you will be able to remember this here, or any form of address, or any form of series of numbers for any website. What we do remember is CXC.com, Facebook.com, YouTube.com. We remember words more. So what basically the internet has is a computer that converts CXC.org to the IP address. There's a device on the internet that converts that. So important to note, the CXC.org is called a domain name. CXC.org is called a domain name, and the actual identification of that web server is the IP address. Now, not sure why I'm not remembering it. What converts IP to domain name? A DNS server or a DNS system. So this is the device here. DNS stands for Domain Name Service. Domain Name Service. So as I just indicated here, CXC.org, Facebook.org, they're called domain names. Hence, the service here, domain name service, the purpose of it is to convert the IP addresses into the domain names. So you don't have to type in the IP address of Facebook and YouTube. You simply type in facebook.com and it converts it into the address and searches for that address. So that's why you don't have to remember any addresses. Are we clear on that? Was that clear?
Yes, sir.
All right. So we just talked about the internet address. The internet address is also called the URL. So that domain name is also called the URL, which is the Uniform Resource Locator. So when you type in www.nationnews.com, that is the URL for that particular website, that address there. What is the backslash used for? The backslash is the double slash, is an address. In an address gives you the path to the computer or the server. So if we even look at the top here, notice we have, but this one here has 3 slashes here. So let me show you at the top here. So if you guys can see at the top here, we have HTTPS : // we have 2 backslash here. So after this backslash here, the 2 backslash, whatever comes after that is the path to the web server, to that website location. A single slash shows you the path you're going to take to access the resource. A single slash is the path you're going to take. So For instance, even while accessing this PDF here, you can see it's showing me the path. Notice showing me some single backslash. So if you notice, it's backslash users. So that means I have to enter a users folder. Then I have to enter another folder called Kurusu Sensei. Then I have to enter another folder called documents, another folder called school, another folder called resources, another folder called IT, and then I access the PDF here. So the single slash shows you the path, and the double slash basically is the full path after that double slash there. Now, what does HTTP stand for? HTTP is telling you that you are accessing a website. Now, if you notice here, can you guys see at the top there? See, there's a file colon. You guys seeing that?
Yes, sir.
That there is indicating that I am accessing a file. I'm accessing a file on my computer. That's what that's indicating there. So whatever's before the colon, that's indicating what I'm accessing. So if you see HTTP colon or even HTTPS colon, that indicates you're accessing a website. So if I switch over to the browser, notice it's HTTPS colon. That's indicating I'm accessing a website. So what does HTTPS stand for? HTTP stands for Hypertext Transfer Protocol. And if you see an S, it basically means secure. So Hypertext Transfer Protocol, secure. We already talked about FTP, File Transfer Protocol, which is used to transfer files. Now, at the end of the website, you're going to see .com, .uk, .edu, .bb, .org. Those are used to identify what is the purpose of what you're accessing. So if you see a .com, it means a commercial organization. If you see a .uk, it means that the website belongs to somewhere in the United Kingdom. If you see a .edu, it means that the website is for educational purposes. BB is for Barbados. TT is for Trinidad. LC is for St. Lucia. Even Guyana has one. Guyana has GY. You guys ever access a website and saw .gy?
Yes, sir.
Right. So that's indicating you're accessing a website that was created in Guyana, that belongs in Guyana. .org is indicating a non-profit organization. .gov is indicating that the website belongs to a government organization. So like if you ever access the ministry's website, Ministry of Education in Guyana, notice it has a .gov. Yeah, if you look at their address here, notice it's a .gov, education.gov, indicating it's a government site, and a .gy indicating it's a Guyanese based website. It's not that it's a Guyanese based website, just that it's created in Guyana, hosted in Guyana. A .net is indicating that it is a network or internet service provider. And if you see .html or HTM, it indicates that the file contains hypertext that is a web page. It basically indicates it's a web page, because if you notice at the end of this file here, you guys seeing it a .pdf? Seeing that?
Yes, sir.
Good. So that's indicating it's a PDF file. So if you look at a website, not all of them show it, because as you're seeing right now, you're not seeing it. Let me see if I switch the page. Yeah, not all of them show it. But if you do see a .html or whatever's at the end, it indicates anytime you see HTML or HTTP, it basically refers to you're accessing a website. Good. So as I mentioned, this here, http colon backslash backslash indicates you're accessing a website. You don't need to type in http because you just need to start typing www. This http is automatically added to the URL when you are searching for the website. So say for instance, if you want to access the file transfer part of the website, you would need to start typing FTTP colon backslash backslash instead of HTTP. Now, as mentioned already, the name of the server is the URL or in the URL, which is the facebook.com, youtube.com, and so on. What else? Whenever you open a website, the first page is usually always the home page. What is a hypertext link? A hypertext link is basically a link that takes you to another page. Those are usually in blue. So anytime you Google search something and you see all of these text in blue, when you hover over it, it underlines. Those are hypertext links. They take you to another location, but not only do they take you to another location, they can facilitate the downloading of files or accessing certain resources and so on. It's not only for taking you to another part of the website. You can access resources using them. Now, what is a search engine? A search engine is basically a software application that helps you to find websites using keywords. So Google is a search engine. You basically type in your words and they search for the websites that correspond to those words. So note, a search engine is basically a software application. So software can run over the internet, can run on the internet. Because remember, these services that you're accessing here, they are being run on a computer. Hence why it can be a software, because it's actually running on a computer. When you type this in here, it's being sent to Google's server so that they can search for this word and give you back the response. What is a bookmark? A bookmark basically means you can save the location of whatever page you are currently working at, so that you can go back to that location, so that you can go back to that page or to that part of the page. Search engines are usually indexed. Basically, they're sorted and put it in a certain order so that you can quickly get back the necessary information. So what is the internet cache? When you're using the internet, your browser store pages and files on your hard disk, because the internet, how the internet actually works is that, remember we said that there's a server on the internet, the web server, and you have your computer here. So this is your PC here. So you access YouTube, but what YouTube is going to do now, YouTube is going to send the video files to your computer. So that is why your internet speed is important, because whenever you access something over the internet, you have to download it to your computer. So that's why if your internet is slow, you're going to access the service slower. Now, pages and files they're stored temporarily in an internet folder on your computer, and that is called the cache. So that you guys ever notice that if you access a website for the very first time, it opens very slow. But if you ever close that website and open it again, it's a slightly faster. Anyone ever notice that?
Yes, sir.
Yes, sir.
Right. So that there is because it's making use of the cache that is being stored on the computer, those temporary files. So it already downloaded all of the images. So for example, whenever I go to ministry's website, it has to actually download all of these images and videos and all of these texts and everything that you see in here onto my computer. So that way now, whenever I go back onto the website, it's actually supposed to load slightly faster, whereby I shouldn't see the images and the information loading. They're gonna already be loaded because I already downloaded them. Now, caching of temporary pages and files is important because it speeds up the display of pages that you have already been to. This is because the computer can access files quickly from the hard drive than from the internet. So they pull the files from the hard drive, but if it needs it from the internet, it would request it. What other services do we get from the internet? We get blogs, vlogs, and podcasts. So what is a podcast? A podcast is basically a audio blog, you can say, where a person is only speaking, you're not seeing anything visually. A blog is where a person can post text, pictures, other personal entries, and so on. But a vlog now is when person is going to use a video. So a video log, or podcast is audio, blog is more of a text and pictures and so on. Great. You guys follow me so far?
Yes, sir.
All right. How long more until we take a break? All right, so we got a few more and then we take a break. Just the chapter is about to end. Great. So creating a web page. How do you create a web page? All websites, all web pages are made up using HTML, hypertext markup language. Note, it's a markup language and not a programming language. HTML is not a programming language. Why it is called markup? Because it is basically marking the location as to where you put various elements on your website. So say for instance, you say that how the heading should go here. That's the heading location. A picture should go here. A secondary heading should go here. Another picture should go here. That is basically HTML. You are marking the location. So that's why it's not called a programming language. It's called a markup language. So it's text-based, and it is a formatting language since it consists of codes which instruct the browser how to create, format, display the information. So that's the only purpose of HTML. So now it uses plain text, and the formatting codes are written amongst the data appearing as markup data. So it uses plain text to create HTML. So that is why you can even use Notepad to type in your HTML code. So for example, what was an HTML code? IMG, can't remember the rest, or H1, and the rest of information. Before I type that, should have easily shown you an image. HTML code. Good. So these are some examples of HTML codes here. Let me look for some simple ones. Yeah, this one here. So notice it's simple text. The second line next to 2, you have HTML, which is a HTML tag. Each line of text that you're seeing in the 2 arrows is what we would call a HTML tag. So we would say this is a HTML tag, this is a header tag, this is a body tag, And if you ever see a forward slash, so I guess I was calling this slash here wrong all the time. So it's a forward slash. Yeah, so if you ever see a forward slash inside of the tag, that means it is a closing tag. So if you notice where you have head, you have two head here. You have one head without the slash and one with it. That means that the heading section starts from the opening head tag, and the heading section is ended where you see the closing head tag. Now, not all tags need a closing tag, so you can take note of that. Not all tags need a closing tag. Basic HTML codes. So what are some of the basic HTML codes you can try to remember? It's not necessary to remember them, but it's always good to try to remember a few. So for instance, the strong tag is when you want to bold some text. Notice we have H1, H2, H3, H4, H5, and H6. Those are used to create various headings in your HTML. IMG is when you want to add an image. I is when you want to make your text italic. P is for paragraph. So it's just like if, think of your HTML like if you're creating a Word document. And you're typing in the information, you're putting in your images, and the purpose of the tags is to format their location, to format how they are going to look, how they are going to appear. That's the purpose there of the tags. So that's why it's called a formatting or a markup language. Now, email, what basically is an email? Email facilitates sending of messages. Each person is going to get an address. The advantage of email is that you can send pictures, sound, video, text as attachment. You can send more than one files. The recipient does not have to be online for you to send a message. Some instant messengers are like that. The person has to be online in order for you to them to send a message so that they can receive it. But with email, you don't have to worry about them being online. You can send that message to that person, and eventually they will receive it. Emails can be sent individually or to a group of individuals. Advantages of an email: ordinary mail would take several days, but email can be sent much faster. For email, you don't have to be as formal. You don't need any stamps, envelopes, so they're basically comparing it to normal mail. Disadvantages of email now. Now, not everyone has access to a computer, and so they will be able to receive an email. Email are not as private as personal letters, so basically any person can go on the person's computer and access their email. And replies are dependent on the recipient accessing the email or reading it. So until they access and read it, only then will they be able to make a reply. So parts of an email address that you should know about. So parts of an email address: before the @ sign is the username, so that would usually identify the person. Then you have the @ sign. After the @ sign is the mail server. So notice we have another server here, the mail server. So this server is going to be used to sending and receiving and storing of mails. And then lastly, you have the type of domain. It's a .com domain. Remember we talked about the domains, a .edu, a .gy. This is for a commercial organization, which is Silver Star Graphics. So you got to remember the format of the email: the username first, then the @ sign, the mail server, and then the domain name. Also important to know the parts of a URL. Let's look at this one here. So the parts of a URL. So the very first part of the URL is the protocol, which indicates what you're accessing. Remember, the HTTP is indicating you're accessing a website. I showed you here that you saw it has file here. That indicates I'm accessing a file on my computer. Now, the domain name. The domain name is basically the name of the company, which is, for instance, Google, and then the type of domain, which is could be a .com, a .org. But if you notice, this one has a subdomain, which is basically like a tree diagram. You have a main domain and then subdomains underneath, like a branch of that main domain. Then after that, now a port number. You don't have to worry so much about that. After the domain name, you're going to start seeing a single slash. Each single slash indicates the path to that to the resource that you are going to. And that's basically the main parts of your website. You notice here, there's different types of domains, top level domains, secondary domains, and so on. What else? File path, parameters. But yeah, the main part is to remember the protocol, remember the domain name, the file path, and that's basically it. Alright, what else do we have to cover quickly? What is VoIP? What is voice over IP? Voice over IP is a internet protocol that is used to convert sound into a digital form or digital data so that you can transfer it over the internet. So it's basically like a replacement for telephone calls. Instead of using landlines to make your telephone call, you can use the internet to make your telephone call. Now, the advantage of VoIP is that you don't have to pay any charges for your phone call because you're using the internet. An example, a smartphone is an example of a wireless device that can deliver voice over IP. So, voice over the internet. So when you make your WhatsApp call, your Facebook call, your Skype call, that is voice over the internet. Even this Google Meet right now, it's using voice over the internet. So this diagram here shows some services that we get because of the internet. We can stream media or Facebook, YouTube, Netflix. We can send email. We can access various websites. We can use various services, various devices to access the internet. We can do our online banking. We can buy stuff online. We can send and receive files, and we can get social media services, communication, and so on. Great. So finally, what are some advantages of the internet? Well, you can find any information that you want on any topic because the internet is open to anyone, except in certain countries where it might have certain restrictions. For educational purposes, you can collaborate, like how kind of what we're doing right now. We're working on completing our topics. We can carry out simulations over the internet. We can do research, gather data, contact experts. So you're not limited to only persons you know. You can reach out to persons around the world, scientists, doctors, even astronauts. If they're online, if they have social platforms, you can reach out to them. You can explore the internet, have fun, play games, have entertainment, animation, video, and so on. With faster internet, it's possible to have more interactive games, better TV entertainment. You can access from the home rather than work, and commercial organizations use it for advertisements, selling goods, providing services, and so on. But what are the disadvantages now? Well, obviously you need equipment, the connection, so you got to pay for it. There is no control of the quality of information, so you don't know if it's good, you don't know if it's bad, you don't know if it's true, you don't know if it's false. So any person can put up any content on the internet, and you have no say, as to if it's good or bad, or what to do about it. What can you do about it? Security. Everything is being accessed over the internet, so hackers can use the internet now to hack the computers, basically. Searching for information is difficult because if you don't know what you're searching for, or if you even don't know how to use a search engine, is going to be difficult. Materials on the internet are copyrighted. Music, videos, and so on, they're copyrighted. So it's not because it's on the internet you're free to use it. Some media you actually have to go and get permission before you can actually use it. And it is possible to download a virus because, once again, you're not in control as to what is on the internet. Anything could be there, and so you can be infected by a virus there. Great. So that brings us to end of our second topic there. All right. Any questions on that before we close off? Any questions, comments, suggestions, recommendations? Or are we good?
We're good, sir.
All right, good. All right, so let me